You download an open model, you cancel your Cloud AI subscription, you run the model on your own laptop, and the interface proudly says local. So your prompts never leave the computer, right? Maybe. The model generating the answer may be completely local while another part of the application is still contacting the internet. A telemetry service may record that you opened a feature. A document tool may send text to a cloud embedding API. A web search tool may upload your query. A remote MCP server may receive part of the conversation. Even the model browser and update checker may quietly connect to external servers. That does not mean every local AI application is secretly stealing your prompts. It means something more important. Local inference and private operation are not the same thing. Think of an AI application as a stack of separate components. At the center is the language model. When you submit a prompt, the model reads tokens, performs calculations, and generates new tokens. If the model weights are stored on your machine and those calculations happen on your CPU, GPU, or neural processor, the inference is local, but the model is only one layer. Around it may be a desktop interface, a model downloading service, an embedding model, a vector database, web search, analytics, crash reporting, plugins, MCP servers, cloud storage, and automatic updates. Any one of those layers can create a network connection, even when the language model never leaves your computer. Start with telemetry. Telemetry usually means operational data collected to understand how software is used or why it failed. It might include the app version, operating system, enabled features, performance measurements, error messages, or usage events. Telemetry does not automatically mean that your conversations are being uploaded. The exact data depends on the software and its settings. But some widely used AI libraries explicitly document telemetry controls because parts of the surrounding ecosystem may send usage information unless that collection is disabled. Hugging Face, for example, documents telemetry used by libraries such as transformers, datasets, and Gradio, along with environment variables for disabling it. Then there are model downloads and updates. A local model has to arrive on your machine somehow. When you search a model catalog, download weights, fetch a runtime, check for a new version, or load metadata from a model hub, the application contacts an external server. This usually does not expose your prompt, but the server can still receive normal connection information such as your IP address, request time, and the model or file being requested. Once everything is downloaded, some applications can operate fully offline. LM Studio, for example, says that downloaded models, document chat, and its local server can operate without internet access, but model searches, model downloads, runtime downloads, and update checks require connectivity. So offline operation is a capability you must verify, not a property you should assume from the word local. The privacy risk becomes more serious when documents enter the workflow. Suppose you run the chat model locally and upload a private PDF. The application wants to perform RAG, so it splits the document into chunks and converts those chunks into embeddings. If the embedding model is also local, the document can remain on your machine, but many AI interfaces let you choose between local and cloud embedding providers. Anything LLM, for example, supports local providers such as Ollama and LM Studio, but also hosted providers such as OpenAI, Azure OpenAI, Cohere, Gemini, and Mistral. If you select a hosted embedding API, parts of your document must be sent to that provider so the vectors can be created. The final answer may still come from a local language model. The vector database may even be stored locally, but the sensitive text was already transmitted during the embedding step. This is why which chat model are you using is not enough. You also need to ask, which embedding provider is processing my documents? Tools create another hidden boundary. A local model cannot know current information, search the live web, read an online calendar, or query a hosted project management system without communicating with something outside the machine. Web search requires a request to a search service. The original query or a rewritten version leaves your device. The returned pages also come from remote servers. Some local AI interfaces explicitly support external search endpoints that receive the user's search query over HTTP. MCP makes these connections easier to build. An MCP server can run locally using communication between processes on the same computer. But MCP servers can also be remote and communicate over HTTP. The official MCP architecture describes both local servers using standard input and output and remote servers using streamable HTTP. Remote MCP servers can expose internet-hosted tools, services, and data sources to an AI application. So you could have a model running entirely on your laptop while it sends selected context to an internet-hosted MCP server. That server might access GitHub, a database, a support platform, or another external service and return the result. This is not a flaw in MCP. Remote tools are useful. The mistake is assuming that a local model makes every connected tool local too. Some platforms blur the line further by placing local and cloud models inside the same interface. One model may use weights stored on your disk, while another is offloaded to a cloud service. Olema, for example, supports both locally executed models and cloud models that are automatically offloaded to its hosted infrastructure. The user experience can look very similar even though the execution location is completely different. So the safest question is not, does this app support local AI? Ask, where does this specific model run, and where does every supporting component send data? Network traffic can reveal the answer. Before an app connects to a service by domain name, it may perform a DNS lookup. The DNS resolver translates that domain into an IP address so the application knows which server to contact. Then the application establishes its network connection. Encryption can protect the content of a connection, but it does not make the connection itself disappear. A network monitor may show requests to analytics platforms, model hubs, update servers, search providers, embedding APIs, or remote tools. Seeing a connection does not prove that prompts were uploaded, but it tells you which components require investigation. So what does a genuinely offline AI system look like? First, the model weights and inference runtime must be stored and executed locally. Second, embeddings, document parsing, speech recognition, image processing, and the vector database must also be local if you use them. Third, every tool must be local. That means no web search, no remote MCP server, no hosted API, no cloud fallback, and no online account dependency. Fourth, telemetry, crash reporting, automatic update checks, and model catalog requests should be disabled where possible. Fifth, download all models and runtimes before disconnecting the machine. Some libraries provide explicit offline modes that prevent HTTP requests and use only cached files. Hugging Face provides an offline environment setting for this purpose, while Olema documents a local-only mode that disables its cloud features. Finally, test the claim instead of trusting the label. Disconnect the internet and see what still works. Use outbound firewall rules or an isolated network to prevent the application from contacting external servers. Monitor its network connections. Then repeat the test while chatting, importing a document, generating embeddings, calling tools, and restarting the app. You may discover that core chat works offline, but model search fails, or document chat works until a cloud embedder is selected, or the model remains local until you enable web search. That is a real privacy lesson. Local AI is not a single switch. It is a chain of components, and your data is only as private as the least local component in that chain. Running the model on your computer is an excellent start. It can reduce cloud dependence and give you more control. But if you want real offline privacy, do not stop at the model. Audit the entire path your data takes. Thanks for watching, and I'll see you in the next one.